All right, so in this particular lesson, I'm going to go over two examples and show you how synthetic division works, okay? When you use synthetic division to divide polynomials, you have to be able to divide by x plus c or x minus c. That x value cannot have a 2, a 3, or any other number in front of it besides a 1. So it has to be 1x plus something or 1x minus something. So in example number 7, what we are dividing by fits the rule for synthetic division. Now, we are going to make what they call a synthetic division table. And our table will have a number out in front, and then we're going to list some numbers back here, okay? So let me take that off and put it in the correct spot. We're going to list some numbers, okay? So how do I find the number that goes in the box? Well, I'm going to take what I'm dividing by, which is x plus 5, set it equal to 0. So actually, I am dividing when x is negative 5. So I'm going to put the opposite of plus 5, which is negative 5, in my divisor box. Now, to complete the table, I'm going to take my polynomial here, the x to the third minus 22x plus 15. And I have to ask myself, am I missing any terms? Just like in long division, you have to ask yourself, are you missing any terms? And should you have a placeholder? Now, a good rule of thumb is based on the exponent x to the third. The biggest power in this problem is an x to the third. So I should have 4 terms. But if you notice, this polynomial only has 3. So I have to identify what is missing. So technically, I have x to the third plus 0x squared minus the 22x plus 15. Now, if I have an x to the third problem, I should have 4 terms. The original problem only had 3, so I had to figure out which term was missing, which was the x squared term, okay? Notice my exponents count down. Exponent of 3, then 2, then 1, and 15 on the end has no exponent. So what I'm going to do is I'm going to write down the 4 numbers that I see, which would be the 1 in front of the x to the third, space over just a little bit, put the 0, which I now have in front of the x squared. Then I'll put negative 22, which is in front of the x, and then my constant number last. This is how I build my table. Now, the process is a repetitive step. So what I'm going to do, I will always bring down the first number in the list in my table. Do not ever change that first number. Once I get that first number in place, I'm going to take what's ever in the box, and in this case, we have negative 5, and I am going to multiply it by whatever number I put below the line. So negative 5 times 1 is negative 5. Notice where I put the outcome of that product. Well, when I put that number in the second column, I will always add these two numbers together. So 0 plus negative 5 is negative 5. Now, I'm going to repeat the process. I'm going to say negative 5 times negative 5, which is positive 25. So I'm going to put positive 25 in the next column. Once I get that number in position, I'm going to add those two numbers. So negative 22 and 25, that gives me positive 3. Then I'm going to take my negative 5, repeat the process again. Negative 5 times 3 is negative 15. I'm going to add those two numbers together, and I get 0. This last number is always my remainder. Now, we just took an x to the third polynomial and divided it by an x to the first polynomial. So x to the third divided by x reduces to x squared. So when I took all the x's out to list, make my column, or make my table, I should say, I now have to put all those x's back. The cool thing about using synthetic division is that your answer will always be one exponent less than what you started with. So we started with an x to the third, and our answer will start with an x squared. So the numbers here, these numbers, represent the numbers that will go back in front of my x values. So let me take some of this out. So you're going to be asked to identify the quotient. The quotient is part of the answer. So my quotient starts with 1. That's a 1x squared. Notice my answer started 1 degree less than an x to the third. Then I'm going to put a minus x. Notice my exponents are decreasing with a plus 3. Now, that is my quotient. Then Alex is also going to ask you to identify the remainder, which would be 0. Or sometimes Alex wants you to put that 0 over what you are dividing by. And in this case, we were dividing by x plus 5. So that's how I put the remainder. The remainder always goes over what you are dividing by. Now, I don't know which way Alex is going to want it, either just the 0 or if they want you to put the 0 over x plus 5. Just pay attention to how Alex is set up. All right. Our second example says to use synthetic division to find the quotient and the remainder. So here again, I'm going to set up my table, my synthetic division table. I'm going to use x minus 2 to decide what goes in my divisor box. So x minus 2, set it equal to 0. That gives me a positive 2. So remember, you always put the opposite of what you see. I technically see x minus 2, but notice I put a positive 2 in my divisor box. Now, I have an x to the third, which means I should have 4 terms. I do not have 4 terms. I have 1, 2, 3 terms, which means I am missing a term. Well, this time I have an x to the third. I have x squared. I do not have just x to the first power, and then I have that constant number on the end. So technically, I have negative 11x to the third plus 19x squared plus 0x. Notice that I put 0 in front of the missing term, and the reason being is 0 times anything is 0. So I'm using that as a placeholder. If you have x to the third as your biggest exponent, you should have 4 terms. I now have 4 terms, even though one of them is simply a placeholder. If you had x to the 5th as your largest exponent, you should have 6 numbers. That biggest exponent plus 1 gives you the number of terms that polynomial should have. Now, will they always have the number of terms they're supposed to? No, this one didn't, so I had to fill in the gap. Now I have all 4 terms identified. I'm going to remove the x, so negative 11, positive 19, 0, and positive 12. Under that positive 12, this is my remainder box. So once again, we bring down the first term. We do not change it. That negative 11 stays. Then I multiply 2 times negative 11. That gives me negative 22. It goes under the next column. I'm going to add that together, and I get negative 3. I'm going to multiply the 2 and the negative 3 together. That gives me negative 6. I am going to add 0 and negative 6, which is negative 6. Then I'm going to multiply the 2 and the negative 6. That gives me negative 12. And when I add, I get 0. Now, just because the 2 examples that I have given you have a 0 remainder does not mean that your remainder is always going to be 0. So always double check your math, but it is a process. Bring the first number down, multiply, add, multiply, add, then multiply, add. Okay. Now, since I started with an x to the third, my quotient will start with an x squared. So I have negative 11x squared minus 3x minus 6. My answer cannot have the same power as my problem started off having, because you are taking x to the third and dividing it by x, which reduces that to an x squared. And then your remainder, I'm not going to write that all the way out. You'll either put 0, or Alex may ask you to put your remainder over what you were dividing by. And in this problem, it was x minus 2. If you have any questions about synthetic division, I would go back in and watch Professor Morris's videos, and he may have a different perspective or a few extra examples if you need them. Please let me know if you have any questions. Thanks.